our second session will be about SQL Server 2019 performance tuning improvements. Our speaker is Fabiano Amorim. He's a Microsoft MVP for data platform from Brazil. He's I've worked with this guy. He used to be from my team, and whenever I have problems for query tuning issue, I throw it to him because he's very good at it. So I'm gonna let him introduce his session and introduce himself. It's all yours, Fabiano.
All right, thank you, Pio, and thanks everyone, and thank you for the invitation to the session. Like Pio mentioned, I do really love to do performance tuning work, and I've been doing it for a while. And let's talk about the SQL 19 performance tuning improvements. There are a lot of improvements in this version, but I actually want to cover a few of them. Let me share my screen. Share screen one. Should be this one. Okay, it should be working. And then, so let's talk about the SQL 19. And again, thank you for the invitation for the session. If you guys are watching this session later on YouTube or the record of the session and have any questions, please feel free to send me an email with the questions and the slides and the scripts that I'm going to use. They should be available. I will also blog them in my blog. So just go to the blog fabiano.com. After 1 hour from the session, I'm going to upload the files there. And yeah, I'm a SQL MVP from Brazil, so I'm really glad to be here and speaking with you guys. So just a bit about me. I do work with Pio at PTN, and I'm a project engineer there, working with SQL most of the times with SQL Server and doing project work for our clients. And without any more introductions, and that's actually me when I started at PTN. That picture is already very old. I'm not sure what happened in 5 years, because that only has 5 years and I'm so different now. I guess I'm getting older really quick. And here's the agenda. I'm going a bit fast here because I do want to show all the things that I prepared for demos. So those are the things that I want to do demos, and actually there is one for this one as well. And I have to start by saying that on this version of SQL, I'm really impressed. And I wasn't impressed with a new version of SQL since SQL Server 2005. And that's where I actually looked at the version and I was saying, looking at the features and studying it, and it was like, wow, that's a really big deal. And I wasn't feeling the same with the other versions like 2012 or even 16. It was okay. I liked the features, they were cool. But now is the first time that I'm actually looking at one version and I'm really surprised and astonished because the performance tuning features are really, really great. And the thing that I like the most in this version is that the only thing you have to do to benefit from the feature is pretty much change the compatibility level to 2019 and you're good to go. So I can see that many clients will be able to use those features really easily without requiring them to go back to the application and changing things there, or implementing a project to implement a feature or something like that. It's just really change the compatibility level and you're good. All right, and then let's move forward with the first item I want to mention is this one. It's the support of the persisted memory drives. So Intel is pretty much the lead of the feature in the market now. So this is pretty much a disk, an in-memory disk that you can use in SQL Server, and then it's a memory disk, but when you put it in the memory slot, and the Windows will recognize it as a disk, and then you can put your database there, or your log file, or something, anything you want in the data in this drive, like tempdb, for instance. And the cool thing about it, it's not only that the performance is awesome because of the memory speed, right? Memory access speed, in both for reads and for writes. But the thing that I really like is that the SQL Server actually is, before I answer this question, the SQL Server is actually now recognizing that you were actually using a driver that it's persisted memory driver, and then it will behave differently because of it. So there are some things that a SQL usually do that it doesn't really make sense to keep doing it for this specific technology. And I will talk more about it in the next slide. So when I first saw these drives, and I was playing with it, and I was reading articles about it, I was thinking that, all right, so now that you can pretty much read at the speed of a memory and you can actually put your database there, does it mean that the performance tuning is something that we don't have to do anymore? So does it mean that performance tuning is dead? So all the work we were doing to avoid a table scan, for instance, do we really care about not doing a table scan anymore if we can do a 20 gig per second scan? Really, so if the table is 5 gig, it's going to take 0 seconds to read the 5 gig from memory. So I was thinking about it, and I think things are changing, and we will get there where in the point where the driver and the hardware, it's so powerful that performance tuning might not be that necessary. But I still think there are some nasty queries, and developers will continue to write queries that are really, really bad. For instance, this is a in clause, you see, and it's a parameterized query. And here's another sample of things that I do love that developers actually do. Here is a replace in another replace in another replace in another replace. And it doesn't really, and my point here is it doesn't matter the performance of your hardware. If users and developers continue to write queries like this, it doesn't matter the driver you're using, the hardware you have, the performance will continue to be bad, because this is really not a disk resource intensive query. This would require a lot of CPU, so we would still have the CPU problem for those queries, and they would still be very slow. It doesn't matter really you're using a persisted memory. So I do think that we still have things to improve and to optimize. Again, this is you see the in clause, it starts here at the row 47, the query, and look at where we are. So this is a huge query. This was actually 8 megabytes query. So that's a 8 megabytes query text sent to the SQL Server. That's a huge query. So performance will still be really bad on those queries. And then let me open a couple of execution plans just for you to have an idea what I'm talking about. Let me try to open this one. Let's see. You see, it takes a while just to open the execution plan. Let me see if it is opening. Where are you? Yeah, let me try from here. Open, come on. There we go. So this is one execution plan. You see I'm scrolling to the right here. And there we go. Look at the scroll bar here at the right. This is huge. Let me zoom to fit. Zoom to fit. There we go. You see, look at this. This is crazy. Let me open another one. So you see, it really doesn't matter that SQL 19 is awesome. You see, you can't have a good performance with things like that. You just can't. So I still think we have a lot of things to optimize out there. All right, let me come back here. And then just to leave you a link, because this one I do not have a disk and a persistent memory disk to play with it with. And so we have to go to the internet and see articles about it. And just to leave one, that this is the new IOPS record that Microsoft had with the Intel Optane disks. So they got, and this is huge, guys, 13 million IOPS per second. It's really IO operations per second is really huge. Just for you to see it, here's the throughput, 535 gigs per second. This is really huge. All right. And then again, when I was looking at the feature, I was considering that so this is a memory disk, right? But what SQL Server actually do when it is reading something from the data file for the MDF file, and it tries to read it from memory. If it is not there in the buffer pool, it is going to trigger the physical I/O operation and then read it from the disk, and then put it in the buffer pool, and then read it from the buffer pool. So I was thinking, if we consider that the disk it's actually a memory, what SQL Server was going to do was it was read from memory, put it in the DRAM memory, and then read it from the memory again. You see, it sounds like there is an extra step that is really not necessary here. And then that's where I told and mentioned that SQL is actually adjusting the engine to use those drivers, and then they are actually understanding that the driver you're using it's a persistent memory, and then it's skipping the step of saving the information into the buffer pool, the regular buffer pool, and then it is just triggering the copy operation from the memory. So this is really cool. And this is actually available since SQL 17, the hybrid buffer pool. All right. There are still some things that I think they would have to adjust. But I was playing with it, and just to play with it, since I do not have a persistent memory drive, what I did was I kind of used I emulated a persistent memory drive, and then you can only do it with Linux. So there are no emulators for Windows. So what you could do is pretty much take part of your regular memory and present it to Linux as it was a persistent memory drive. So just a couple of links for you to be able to do it and play with it. The emulator is not that good. So when I played with it and I tried, I didn't really like the tests. I was expecting the much better performance. I wasn't really able to see the real benefit of the feature. But again, I spoke with Microsoft about it, and they blamed the emulator. So if you really want to see the performance of it, you have to get in your hands one of those drives. All right, and now let's go to the cool features that I'm actually going to show them. So since 2017, there are these new set of features that Microsoft it's calling the query processing, intelligent query processing features. And it's pretty much the intelligent query processor that there are features that the query optimizer it's actually getting smarter, and then it's understanding from its mistakes and then behaving differently to avoid something that he understood was not really well. And then the first feature that I want to show here is the row memory grant feedback. That this feature actually exists on 17, but it only works for the batch mode operations. And now in the SQL 19, it works for both row mode and batch mode operations. So it doesn't matter if you do or do not have a column star index in the tables. So let me show how cool this is. So I have a script here. I'm still using the Northwind database as a test. So I'm going to create a new table called products big here. And then I'm setting the compatibility level to SQL 17, okay? So I do not want to have the feature, so I'm disabling it to show you the problem first and then how the feature works. And the feature, it's really straightforward. If you have a query that for some reason it's spilling data to TempDB, then the query optimizer will identify that the feature it's actually using the TempDB to process something, and then in the next execution of your query, the query optimizer will try to ask for more memory. So that's a memory grant feedback. So just to show you here, I have a query selecting products big and ordering by call test. And if we look at the execution plan here, it is going to read all the rows from 1 to 756. And then it's going to return all the rows to the sort operator. And then the sort will actually use memory because it has to keep the rows that it's receiving in memory and then process the sort operation in memory and then return the rows to the select operator. And the problem with this is that sometimes if the memory the SQL Server reserve to process this query is not enough, then you see, for instance, if I ask for just one more row, then you see that in the actual execution plan, now we have a warning here in the sort, and the warning is saying, A, the operator used TempDB to spill data during execution. And that means that at the execution time, the query wrote a lot of pages into the TempDB, actually 757 pages to the TempDB, and then the memory grant it has was 6 megabytes. And then we can actually see the memory grant here as well. So select properties, and then we have the memory grant info here. So you see that the memory grant it acquired, it was granted, was 6 megabytes, and it wasn't enough. And the way it works is just like this. Before it starts the execute the query, SQL Server will estimate how much memory it needs to process the query. And then if the memory that it estimated is not enough, then SQL will actually use TempDB to process the operation. And the performance with one case and another one, it's really, really different. So just for you to have an idea, because I ran the query here, see, I'm actually flushing in the buffer pool, and then I'm clearing the plan cache. And then if I run the query, you see that the performance is really fast, right? It's 0 seconds. But actually, if I compare to the one that it's not using TempDB, the performance is really, really different. And to compare this, let me open the SQL query stress here. And then I have configuration here. So I'm going to run this query at the Northwind database, I will open 20 threads and run 5 iterations on each thread. So I'm kind of stressing the query to see the performance. And if I run this one that actually goes to the TempDB, look at the performance here. And while it's running, let me show you something, the resource monitor here. Let's see if I can catch it in time. Yeah, I do. So you see it's still running, and I'm writing here the tempdb file. So you see I'm writing 41 megabytes and reading 38 megabytes per second. And the response time, it's about the latency, it's about 35 milliseconds. So what's going on here is that while the query is running, and while you have many users running the query, I'm using tempdb a lot, right? Pio, if you have questions, I'm not sure if you're moderating the chat. If you have questions and you want to stop me, feel free to do it, okay?
Yeah. Well, I'm gonna pass it to you when a question comes in.
Awesome, thank you. All right, so you see that TempDB is being used a lot. And then the query that was actually taking 0 seconds in the management studio, once you applied to the production environment and you had 20 users running the same query at the same time, the performance was, you see, a lot slower. So it took 34 seconds to run this query. And let's say this is a problem that you have in your environment, and I'm 100% sure that you do have queries spilling data to TempDB in your environment, and you can look at the default trace to make to check if you do have it. So what do you have to do to fix it once you migrate to SQL 19? Is just change the compatibility level. So I'm going to change it. Now I'm using the 19 version, and then I'm going to run exactly the same thing. And what it is going to do now is that SQL Server will understand that the first execution was actually wrong at the memory reserved to process the query, and then it is going to adjust the memory grant for next executions. So let's see how much time it's going to take now with the new compatibility level. All right, let's go. All right, so 8 seconds. Okay, that's good enough, but let's try again. And there we go, 0 seconds. So you see, this is the memory grant feedback feature working and adjusting the memory grant size of the query automatically. So just for you to see here, this is happening. So I'm going to clear the procedure, the plan cache, and then the first call of the query will have a plan that it's actually going to the TempDB. So if we look here, we have the memory grant of about 6 megabytes. And then if I run the same query again, look at what happens. Let's try again. All right, there we go. Sometimes you have to run 1, 2, 3 times until the memory grant feedback actually kicks in. And now you see I do not have the warning anymore here. And now the memory grant is actually 18 megabytes, and that's perfect. And if I run it again, because it's 18, but it's actually, let's see how much it used. These are maxed use. You see, it used only 6 and it got 18. Let's run the query again. There we go, 9 megabytes. So you see, even it works for both sides. If it asks for too low, then it is going to spill to TempDB. And then the next time it's going to ask for more memory. But if it asks for too much, it is going to adjust it to ask for a little bit less. So that's really perfect feature. So the only thing you have to do is just go and enable the compatibility level. All right, and it works since 17, but on 17, to be able to use the memory grant feedback, you have to have a column start index, but it only works with the batch mode operations. And now on 19, it works for both row mode and batch mode operations. And if you're wondering, and what is the batch mode operations? There it is, the batch mode over row star. And let's go to the demo right now. And this is a friend of mine that I like to call him Demo. Yes.
Yeah, we have a question on the chat. Warner is asking if the feedback does not persist beyond restart, right?
Oh, yeah. So the memory grain feedback relies on the query plan that is in cache. So you see that once I cleaned up the cache, the next execution will not use the memory grain feedback. So if I run this, it's not spilling to TempDB, but once you clean the cache, then you're back to the problem. But you still have the problem, but only for the first execution, because the second one, hopefully the memory grant feedback will kicks in again and fix and adjust the memory grant. So it relies on the query that it's in cache and not in the query store, for instance. It would be nice to have it looking at the query store plan, because then you would have it persisted there. But if you restart the server or clean up the cache for some reason, or have a memory pressure that for some reason removed the plan from the cache, then you have the problem again. All right. All right, so that's the batch mode. Let me talk about batch mode here. Batch mode rollover row star. So again, now I'm going to do two demos, two queries I'm going to run. The first one is it's using the wide world importers data warehouse database, setting the database compatibility level to 19. And then here's what I have. I have two queries that I'm going to run. The first one, I will run the query not allowing a batch mode. And then I'm going to run the second one, exactly the same query, allowing the batch mode. And then let's compare the performance of those queries. And what I want to show is that, again, it's a really cool feature. And the performance, we can look here at the execution plan query time stats. So the first execution took 167 milliseconds. And then if we look here, we could see, so I'm looking at the column star scan here. We can see here the batch mode, the execution mode, it's actually in using the row mode. And then in a few words, what this is doing is that for each row, it is reading from the column start index, it is returning the row to the next operator. And that's just the way it works by default. That's the row mode. So that's a row by row read. And then in this one, you see that it's using batch mode. What it actually does, it reads a few rows at the same time. So it reads a batch of rows. The exactly number of rows depends on the number of columns you have in the segment. So it usually goes from 16 to 900, up to 900 rows for each read. And then there are some other specifics that makes the batch mode rows read for many rows a lot faster, especially when it's running in parallel. But the cool thing is that because it is not reading row by row and it is reading a batch of rows per time, then the performance is a lot better. So you see that now this one only took 10 milliseconds. That's a huge difference. And the only thing that I changed is that one it's using the batch mode operation and the other one it's using the row mode operation. Again, the only thing you have to do is enable the compatibility level and you are done. All right, so SQL Server is still the one deciding whether to use batch mode or not. So it's still a cost-based optimizer decision to use it or not. So you can try to force it, but at the end, SQL will decide for you. The optimizer will decide for you if he wants and if he thinks batch mode should be used or not. You can force-ish, but yeah, query optimizer will decide it for you. And it has many things it takes in consideration to decide whether to enable it or not. So the table size, for instance, the operators use it. And then just to give you one sample, I have here two tables, one with 131,071 rows, you see, and the other one with just one row more than the other table. So I have two tables. And if I try to read them, let me use Northwind here. So you see I have the query reading the table with 1 here, and another query reading just one more row. And both of them are allowing batch mode to be used. And if I run them, if we look here in the query time stat, so the first one took 508 milliseconds, and the second one took same time. Let me run that again. That was too much. Okay. So the 53 milliseconds versus 10 milliseconds. Okay. And the difference that the first one did not use the batch mode, and the second one, it's actually using the batch mode. So you see that the number of rows, it's something that Query Optimizer takes in consideration. So depending on the number of rows you're going to read, it might enable batch mode or not. And then you could actually try to override the batch mode heuristics here using this hint. And then even reading the table with less rows than the threshold, internal threshold, I could benefit or enable the batch mode, you see. Oh, this is one thing that you could try. And then for more information about it, you could look at the this blog post for a friend of mine, the Russian guy. So this is a really cool blog, by the way. If you like performance tuning, you should read all his articles. All right, so this is the batch mode. Cool feature again. And then another one is a table variable deferred compilation. So table variables are a problem for a long, long time in SQL. And the problem with the table variables is that, again, creating a table here to use in the tests. All right. And then setting compatibility level of 17. And then the problem with a table variable, it's that, you know, the SQL, the Query Optimizer doesn't know how many rows you actually have in the table variable because they do not have statistics. So every time you read the table for some reason, now here's what I'm doing. I'm reading customers, but I only want to return customers that actually are in the table tab 1. And so this is actually cool, right? You can use star here in the one column. Yeah, you can, but only if your table has only one column. So in that case, my table variable only have one column. So so you see, I'm inserting some rows here from the customer's big table, and then I'm trying to read only the rows that actually exists here in the table. And then if we look at the execution plan, this plan is not really good because you see here the SQL, it's reading the table and estimating that only one row would be returned from this, and then trying to seek the row in the customer's table. And you see, it thinks that the rows that are actually going to match from the loop join, it's only one. But actually it returned 49,000 rows. And then it caused another problem that the memory reserved to process this distinct operation, because I'm selecting distinct in a query, it was not enough, and then it spilled data to TempDB. So there are all sorts of problems just because the number of rows estimated to be returned from the table variable, it's 1. And what changed in SQL 19 is that the query optimizer is deferring the compilation of the plan to after it reads the number of rows in the table variable. Once it knows how many rows it has there, then it is going to decide what to do with the execution plan, which batch to follow, which plan to create. So for instance, let me do the same thing, but with the compatibility level of 19, exactly the same query. You see now that the plan is very different. We do not have spill to tempdb, and there is a hash match here before actually do the join. And if we look here, the estimated number of rows, it's perfect. So based on this cardinality, then it is going to decide what to do with the plan. All right, so this is just the way it works. So no more need to use temporary tables, Fabiano, right? Not so fast. There are still some cases where you should use temporary tables instead of table variables, and I think you should be using in almost all of the cases, almost. But here's one sample. I have heard some people saying, for instance, that it's okay for you to use temporary table variables if you're actually inserting just a few rows in it, and it is not really true. For instance, let me create a table here we're going to use for the test. Here's what I have. I have a table variable here, and I'm going to insert only one row, all right? And then I have a query that it's actually using the table variable. So I'm reading the orders big and joining that table variable. So that should return only the row that actually match, right? The order ID or the customer ID 1. And then look at the execution plan. And remember, I do have 19 enabled, SQL 19 compatibility level. So the deferred compilation, it's working. But now I only have one row, right? So it doesn't really matter that it was already estimating one row. But let me run it for you. And if we look at the plan here. So first of all, it took 2 seconds to run. And if we look at the plan, you see, it estimated it was going to return one row, and it is right because it only exists one row. And then it is doing the plan and whatever, it's scanning the table. So, all right, it is scanning the table, running in parallel, nasty plan, taking 2 seconds to run. And what happens if I do exactly the same thing with a table, a temporary table that do have statistic? Then look at the plan and the performance. There we go, 0 seconds, and completely different plan. Now it understood that it's going to return only one row from here, and then it thinks it's okay to do a key lookup. So you see, there are still cases where you need to use temporary tables instead of table variables. So I do recommend you use temporary tables in most of the cases. All right. Okay, so next one is the Scalar Udf Inlining. Let's go to the demo again. All right, so again, creating a couple of tables we are going to use in the test. And then here's the feature. Scalar functions, so also known as functions that return one specific data type, something, return a varchar or int or something. Scalar functions are really, really bad for performance. And that's a problem for a while as well, because they run row by row, right? They are executed for each row in your query. And this feature of automatic inline scalar functions, it's really, really cool as well. So in the SQL modules table, system table, there is a column here. See, it's called is inlineable. And for the function that I created, it's marked to 1. So yes. So I'm doing a really dummy thing here based on something that I received. I'm going to return only the the right of something in 2 characters. In this case, I'm going to use 2. So for instance, let me call the function here so for you to see what this is doing. So let's say I'm trying to read based on Fabiano, only the last 2 characters. Not working. Car 2. What did I do? Oh, because the result is int. So sorry, my bad. It's 3, 4, 5, 1, 2, 0, 5. There we go. So it's returning only the last 2 characters. So this is what the function is doing. And here is what I have to show the problem of this. So I'm disabling the inline function here using this hint. And here's a query I have. I'm reading the orders big table and the column value. So let me read the table here just for you to see what's in it. So I have a column value here, see. I'm actually summarizing all the decimals here, see. So the last 2 characters. So that's what I'm doing. The table has 1 million rows, and then question, how many times do you think the function will be executed? So if the table has 1 million rows, how many times would you expect the function to be executed? 1 million, right? Not so fast. And the problem here is, let me run it. You see that it's taking some time to run, and it is taking some time because of the function. And the problem here is not only that the function is bad, but the function is actually bad and you're actually running it twice per each row. So you see I'm reading, it's actually 2 million rows, okay, in the table. So I'm reading the rows here, and then I'm aggregating because I have the sum. And if we look at a string aggregate here, and then if we go to the defined values, I'm expanded here. You see that we have 2 expressions being calculated here. So one is this expression and the other one is this one. And one is actually doing the sum, and here's the function being used. And another one is count big, and here's the function being used. So for each row, the function is going to be called twice because the string aggregate is actually returning 2 things. Even though you're not asking for the count big, the string aggregate actually requires it to the sum. And the reason it requires it is that because if you do not return any rows, then it has to return no, because you know if you sum something from a table and the table is empty, then you're not going to receive an empty result set. You're going to receive no result set. In this case, I would probably have the 0 result set. So, and this is the problem. 1, the function is really bad for performance, and 2, the function is being executed twice. And if we look at here at the query time stats, we actually have new information here in the query plan. 16, I think, SQL 16, we have the UDF CPU time here. So you see the query took 8 seconds to run, but only executing the function, SQL took 7.5 seconds. This is really, really, really bad. And one of the things that everyone is well known that you could do to optimize a function, a scalar function, is to convert it into an inline function. And an inline function is the function that returns a select statement. So instead of returning the int value, I'm actually now returning the select something. Okay, and then instead of calling the function here, I have actually to cross apply with it. So that's the inline function. And then the performance here, it's really, really good. You see, 0 seconds instead of 8 seconds. That's perfect, right? But what's the problem is that you have to rewrite your query. You have to use cross apply. You have to create an inline version of it. And then on 19, the feature that we are talking about, the automatic inline function, it's inline scalar function. It's that SQL do it automatically for you. So if I run the same query without the disable scalar UDF inline, you see that here's the performance, 0 seconds, right? That's perfect. So what I would expect is that all those queries that you have inline functions that are able to be inlineable, then those queries will be a lot faster. Okay. All right. Let me move forward here. Otherwise, I will not be able to show all the things. So the next demo is the accelerated database recovery, and that GIF, I really like it. It's here is the representation when you remember that you were out for lunch and you remembered that you let the transaction opened. You forgot to commit the transaction or to roll back it. The problem with this is that, you know, if you start a transaction and start changing a lot of things, all those things will be written to the transaction log. And then the transaction log, that information will not be cleaned up if the transaction is opened, right? And here's the problem we have that is very common. The rollback process of a transaction takes forever. And this is one of my favorite features in the 19. It's the accelerated database recovery. And here's how it works. The idea is to make the rollback process a lot faster than usual. So here's what I have. So let me close all those sessions. All right. Not sure why it's taking. Let me see. I probably blocked by something who is active. Yeah. Cool. Oh, it's probably SQL query stress. Let me close it. Okay, let's see. Still blocked. Yeah, let me kill this session. Who is blocking me? 60. Okay. Oh, that's me. All right, there we go. So I'm just making sure that accelerated database recovery is off in the database we are going to use for the test, and using Northwind. And I have here a table called the big table. Let me see if it's there. Yeah, it is. So it's a table with about 2 gig size in 2 million rows. And here's what I'm going to do. I'm going to run this delete as a developer with production access mode. All right. So I was supposed to actually run the delete statement selecting the where clause. But you know, I'm a developer and I'm connecting it to the production database. I'm going to run the delete statement. And oh my God, I forgot to select the where clause. But yeah, I'm only going to notice this, that I forgot to select the where clause after 13 seconds. And then now it's been already 20 seconds and now I forgot it. And then what I'm going to do is I'm going to hit cancel button, cancel. And then, you know, it is going to cancel because that's an implicit transaction here. And then, but I'm trying to stop here and then it's not stopping. It says that it's canceling the query, but it's not canceling. Let me try to close this. Yes, let me close. Yes, I want to cancel it. Please. You see, I'm desperate. And then I'm going to check who is active to see if the query is still alive. And oh my God, the query is still alive. Let me kill it. Please, I want to cancel. Oh my God, the query is still alive. So the next step you are going to do our favorite thing. You're going to stop the engine, the service, because you're desperate and the query is still running and you do not want to delete all the rows. Stopping the service. Come on. Go ahead. All right.
Is this from true to life experience?
Oh yeah, that who never did it, right? I've never done a delete in production. All right, so it's finally back. Let's see if so the query finally is finally dead, but let me refresh here and see what's going on now. And hopefully it's going to work. Let's see. I can also in the meantime select from databases. And then let's see the Northwind database here. Oh, you see the state for the Northwind database? It's in recovery. So, you know, everyone did it once, at least once in production. It was desperate. And then, you know, going back to the real life, you have this maintenance plan that you have to apply, the change in the application. And one of the things that you are going to do in the application change is that you are adding a new column in a huge table, and then the other table statement was taking 4 hours and did not finish yet. And then we're almost running out of the window you had to do the maintenance. And then, all right, you decided since it is taking 4 hours, it didn't finish yet, I'm going to stop it and I'm going to continue tomorrow in the next maintenance window. And once you try to stop it, it wasn't stopping, and you realize the query was still there and still running, and you try to kill the session, and then you restarted the service, and then your database came back in recovery mode. And that's just because the way it works, right, guys? It has to roll back the transaction that you were running. And usually the rollback process takes a lot of time. It should be done already. Let me refresh again. Yeah, it is. And then I could go to the SQL error log to see how much time it took. Yeah, there it is. So the recovery for the Northwind database took 37 seconds. So you see, it has to do the recovery process. There is no other way. That's just the way it works. And then the feature of the accelerated recovery database that I mentioned, it's really cool. Let me enable it. All right, it's enabled. Let me use the Northwind. And what it actually does, it has some techniques and some things it do internally to make the recovery process a lot faster, almost instantaneously. It usually takes 0 seconds. So for instance, if I run the same query, what it does, it kind of relies on versioning, and then it creates small checkpoints in the log, transaction log. So let me leave it running for 20 seconds like we did before, and then I'm going to stop it. So 20 seconds and then stop, and done. We are done. You see, the recovery already happened. And if we look at the table, let's see here how many rows we have in the table. We should have 2 million rows, right? Let's wait for it to read the 2 million rows. And yeah, that's just the way it works. You see, we do have the 2 million rows here. So one thing that I noticed that the feature is really cool, but it kind of internally, you see, internally, it kind of messed up the statistics. You see the estimated number of rows is wrong here, and actually, if you go to the SP space used and check the number of rows in the table, look at there. You see that the number is changing. That's because there is a cleanup thread that it's actually adjusting the rows internally. And there we go. The cleanup already ran, and we are back into the 2 million rows. Just a quick thing about the internal, there's this behavior that while you're waiting for the cleanup process to run and to insert the rows back into the table, the estimations, the statistic, it's a bit wrong. But this is it. The feature is really, really good. And as you know, the version star will have to use some space. So you need more space in the file. It does not use the tempdb, all right? So it actually used a local primary file group space. And if you do not want it to use the space for the primary file, because you may not have space in the file, you could create a new a new file group and a new file in the file group, and then specify the version star file group for the persisted, versus star for the Scalar database recovery. This is really cool, right? You could have your own temporary database for this this feature, this versioning.
Yeah, we got a couple of questions.
All right.
Yeah, so for 2019, for snapshot isolation, is it also gonna use it? Will it still use TempDB, or is this only for ADR?
Yeah, that's a good question, and I don't know the answer. I think it's still using TempDB, but I don't know. I would have to try to make sure. So the answer for this question is, I think it is still using TempDB and only using the file group that I specified here for the accelerated database recovery. But I don't know.
Is it enabled by default, ADR?
No, it is not enabled by default. It is enabled by default on Azure, I think.
Yeah,
so in a SQL, in a SQL database in Azure, it's enabled by default, but not on premise. So once you create a new database or recover a database from a backup into 19, you will have to enable it. It's off by default.
We have another question, but it's on the temp table information.
All right.
We have a question from Ray Delara. I got confused on table variable versus temporary table. What if I only have few rows and I decided to use a temp table? Won't it be faster to use table variable, especially if your temp table has an index that needs to be updated too, unlike on table variables?
So the answer is no. Internally, they are exactly the same, temporary tables and table variables. So there is not such thing as the table variables are in memory, unless you actually use the in-memory feature of 19 and then define that it's schema only. So internally, they both could go to tempdb and disk file. So so the answer is no. Even though if you have a few rows, usually, all right, it's not always, and that's why I mentioned the word usually when I talked about it. Usually the temporary table, because it has statistics, you will have better plans while reading or modifying the temporary table of the data. Okay. All right, and then I do have a couple of 3 other demos here, but I don't think we have time for it. So I will leave it for maybe the next version of this session. So just want to go really quick about it. So there's this lightweight query profiling. You could enable a scope database configuration. Well, let me show you the scope or the trace flag. So you see that you have now the scope configuration of last query plan stats. You can enable it to on, and once it is on, you could actually, let me enable it, and that should be really quick. So I'm running a query here, and then you have access to this new DMV here, is exact query plan stats, and I'm looking at the KPS star here, so all the columns. And if I look at the query plan here that it's in cache, here's what you have. Oh, actual number of rows for the query plan that it's in cache? Yes. So that's the cool feature. You have actually the last executed plan, the last actual execution plan in cache. So that's really cool. And then you have the SP estimated data compression savings also working for column store and column store archive. So you could use the column store, for instance, to compress big tables, including for tables with XML columns that are in varchar max or varchar max that are page and row native page and row compressions do not compress, and column store does. There are some limitations, but they usually do. And then you have the new weight type called a weight on sync statistics refresh. So you know when auto update statistic is triggered, and your query is there waiting for the auto update statistics to finish before it creates an execution plan, you're just there waiting for nothing. By default, up to 17. If you have a query that it's waiting for the auto update statistics to finish, and you look at the exec or waiting tasks, you will not see your query. So you really don't know what's going on with the query, why it's not running. And now they finally added wait for it. So if auto update is running, you see that the wait on sync statistic refresh is actually there. And other improvements, there's the TempDB memory system objects. There's the MDB page info to replace the DBCC page. There are many compatibility level hints. You could check the hints in the exact valid hints, use hints DMV. There's the approximate count distinct. Other features that might be in the project in the future. For instance, this one I really like is the results head caching. This feature actually already works for the SQL data warehouse, but we do not have it yet. Who knows in the future? TempDB to remote store, that would be nice as well. So spill TempDB into a different database. So kind of the TempDB with its own database. Snapshotting views. So some features that are we kind of see them in the product, but they're not there yet, not complete. Yeah, but are worth mentioning. So again, guys, if you're watching the record of the session and want to ask questions, please feel free to do it. And here's my email if you want to send email as well. So I already over 2 minutes of the time.
Yeah, that's fine.
This is it, Pio. Any other questions? Let's look at the chat here.
There's one more question about SQL query stress tool.
Okay.
Yeah, so she's asking where she can get it, and the pages are showing deceptive page, or it doesn't exist. I'm not sure which pages you.
The pages are showing. The pages are showing deceptive pages. I'm not sure if I understood the question on the pages, but Lena, the query stress, you could just Google SQL query stress. That's actually is a free tool you can download. So Adam Mechanic actually wrote it, but now he published in its in the code. It's public, so it's in the
I think
GitHub
he put it in GitHub. Yeah, I sent her the link, but I think that's the old one. Yeah. But yeah, I think he moved it to GitHub, so you should be able to find it there.
Yep.
Oh, there you go.
Yeah, perfect. Yeah, thanks, Warner. And what else? Any other questions, guys?
Let me just quickly check again on the look. Yeah, looks like we answered all the
Yeah,
questions.
I like it, the note of Warner that prepare your resume while it's all hung. Yeah. Once you restart the service, oh my God, you would start calling people and say, hey, my database is in recovery mode for 6 hours. I don't know what to do. Yeah.
Oh, but it's unfair to say that it's a developer who did it, because I've known a junior DBA who have done that. So
All right. Yeah, I agree.
gotcha.
Yeah.
Yeah.
At least I think in SQL 2012, the only thing that actually get blocked is the table that is being restored, right? So you could actually access the database while it's in recovery mode, but the only thing that you can't access it is the table. But I think prior to 2012, the whole thing is blocked.
Yeah. So yeah. Any other question, guys? Yeah, definitely. One was saying is the difference between a junior DBA and a senior DBA is the senior DBA already screwed up production at some point, at many
Yes,
points in the past.
that's true.
Yeah.
All right.
Yeah. So guys, if I put the evaluation link at the chat, if you guys want to, if you have time, kindly evaluate Fabiano's session. Uh, I'm counting down. Any more questions? I think that's all. Uh, Thank you, Fabiano. Very nice session. Uh, that's all for tonight, guys. Like I mentioned earlier, we won't have any session next week because the Office 365 group will have their monthly meetup. We'll resume July 14. We already have a speaker lineup for you. Watch out for the posts for that. That's all. Thank you, everyone. Good night and good morning
Yeah.
to you.
Thank you, everyone. Thank you. Yeah. Thank you,
Bye bye.
Pio. Thank you. Yeah, bye-bye.
Thank you.
Take care.
Thank you, Pio. Boa noite. That's good night. Boa noite.
Yeah, to the bang.
All right. Bye. See you, man.
Bye-bye.
Thank you.